questions. So we're going to look at small angle approximations. So given that theta is small and measured in radians, use the small angle approximations to find an approximate value of this. Okay, very common year 13 question. I don't remember this being on the course when I did the A-level. I first saw this at university. It's not overly difficult, but it is easy to mess up. So using small angle approximations, it's telling the thing it wants you to use. Now, you probably remember the only dodgy one is the cos one, which obviously this question features. So if theta is small, it kind of ties in with the idea of limits. We're looking at like the net effect of the behavior. So what we should know, and this is basically getting us the first mark, is correctly identifying what the small angle approximations are. So give that stage a tick in your book that that is your first mark. Sine 3 theta is approximately 3 theta, and cos 4 theta is 1 minus 4 theta all squared over 2. Okay. And again, welcome to anyone that's joined. We're just going through exam technique, and then we'll be moving on to some trigonometry. Right. So this is what we're going to get. And then we're going to actually substitute that in really carefully to here. Now, there's something very common in the design of this question that catches people out. And I've been caught out by this plenty of times, where there's already a 1 minus cos of something, and the cos double angle has a 1 minus in it. People just forget to put the extra 1 minus. It's 1 minus brackets 1 minus all of that. Another common mistake, try and anticipate it, is not squaring the 4 as well. It's 4 theta all squared over 2. So there's lots of fractions in fractions. It will tidy up, and we'll get 16 theta squared over 2 all over 6 theta squared. The theta squareds will cancel out, and then your third and final mark is for there. So I'd say the first mark for the top line, the stage where we're about to simplify it, a second mark, and the final mark for the correct answer. Right. So let's keep going. Yeah, cool. So for this one here, we're told that the depth of the water in a harbour on a particular day is modelled by this. So you're given that D is equal to 5 plus 2 sine 30t, and T is the number of hours after midnight. So a boat enters the harbour at 6:30, takes 2 hours to load its cargo, and it requires a depth of water to be at least 3.8. Find the depth of the water, find to the nearest minute the earliest time. Right, so units are really important here. The depth is in meters, and also the time, and we should also be paying attention to AM or PM and all that stuff. Right, so let's have a little look. So this bit here and depth. So this meters. And then I would say you actually want to give the time. So this comes back to we want actually in hours, minutes, and seconds. We don't just want 1.21 hours. We have to contextualize that in a minute. So let's have a little look. So 6:30 a.m. These sound like basic things, but it's easy to mess this up. Is 6.5 hours after midnight. Really easy to do that wrong. So that's what we're subbing into the angle. Now from there, what we're going to do is that's going to give us a mark for doing that correctly. If we put 6.5 in, that's actually a mark. Then getting the minimum. And that is, you only get that mark if you put the units. Okay. The next one, setting the minimum, rearranging and solving. So there'll be a mark for this. There'll be a mark for this. And then there'll be an actual mark for solving that. Okay. Now, solving this carefully, we know that there's infinitely many values to that. There's many potential values due to the like infinite repetitions. So we have to look at the domain. We have to look at the restriction. And 8.5, T has to be greater than 8.5 because they can't start loading the cargo till 8:30, which is 8.5 hours after midnight. So we have to solve with that little restriction. And so what we know is the values that will work. The only acceptable one, when we divide by 30 and so on, would be 10.77. Now remember, that's 10.77 hours. That's not that handy. So we want to convert that to a time using base 60. So if you've got like the ClassWiz or the older calculators, you'd write 10.77, and then you could use this button, which will turn it into 10.46 as a time. If you're doing it an old-fashioned way, or you're using a different calculator and you can't find that button, then you can just keep dividing, find like 0.77 of 60, and then you get it in minutes, and then you can do it for seconds. But we want it to the nearest minute. And also note that we'll say AM. Make sure it's clear what time of day. So these are one of the modeling in context questions. Brilliant. Right, a few other little points, and then I think we'll take like a 5-minute break, and then we'll be ready to move into the trigonometry, which is going to be quite a full-on session. Again, welcome to anyone that's joined. Let's keep going. So a few things to point out, just depending on your exam board, there are different formulae and different things that you have access to. Go on either your school website or your exam board's website and make sure you're 100% familiar with what they give you, because if there is anything missing that you need to commit to memory, it's probably worth like doing that now. So don't leave it too late, but just be like, okay, if I don't need to remember all of these integrals, but it's handy to know some of them, or just know that they're a thing and know that they're in my formula book. Right. Basic recap of trig. We should know all of this stuff. And from year 12, we should know the two main identities, that tan is sine over cos, sine squared plus cos squared is 1, because off the back of those, we have some new identities in year 13. We have 1 plus tan squared is sec squared, 1 plus cot squared is cosec squared. So these lead us to some new identities as well. Right, so new identities. I'm going to add those in. And 1 plus cot squared theta, which you can derive from the year 12 one, but they're handy to know as well. Okay, brilliant. So let's keep going. Considering the units now, just top tips for mechanics. I did also say this yesterday, but I want to really reiterate this. I can't stress enough for mechanics how much the force diagrams are important, especially on slopes. Just take up as much space as you need. Don't do a little scrawly little drawing, make it really big, because mechanics is tough to visualize. So do draw it nice and big, nice and clear. Let's keep going. So the large data set, as I said, the main things you want to know or be familiar with are like the headings, the units, especially the weird units, the uncommon ones, limitations, anything that's missing, and any context that might be really important to refer to. As I said, you don't need to like learn values off by heart. So most of the large data sets, you go on your exam board website, there'll be some information about it as well. So maybe focus more on that.